my group specializes in the use of this technique known as comprehensive two-dimensional gas chromatography, and we generally abbreviate that to the phrase GCGC. Comprehensive two-dimensional gas chromatography system is very similar to what most people know about one-dimensional gas chromatography. So basically in 1D GC, you inject your sample, the inlet is hot and it vaporizes whatever you've injected if it's not vaporized already. Then your sample moves through a column that's coated with a stationary phase, and depending on the analyte's affinity for that stationary phase, your sample is going to separate from the analytes in your sample will separate from one another and ideally arrive at your detector one by one, single file. Putting their hand up in the detector identifies who they are, right? So in comprehensive two-dimensional gas chromatography, what we're really trying to do is increase the ability to have a higher separation capacity. So thinking about those analytes trying to arrive at the end of the column one by one, when you deal with a sample that's really complicated, that might have hundreds or even thousands of compounds in it, that separation process is really challenging. And so when we use comprehensive 2D GC, what we do is we collect what's coming out of the primary column, which is the exact same as the column that you'd see in 1DGC. So you're collecting for short periods of time. It's usually a few seconds. So you collect for a few seconds and then you use like a fast injection onto a secondary column. And that secondary column is a little bit shorter and has a different stationary phase on it. And that allows a small plug basically to be separated on a different retention mechanism. And so by doing that, you vastly increase the amount of capacity that you have to separate these analytes because you're separating them first on the primary column and then doing like a secondary fast separation on the secondary column.